Today I'm going to be talking about special right triangles. So we have two different types of special right triangles. We have a 45, 45, 90 and a 30, 60, 90. What we have here is our 45, 45, 90. And when we have a 45, 45, 90, when those two angles are congruent, that means these two sides or legs are congruent. So they're both 1. To find out what the hypotenuse is, we're going to use Pythagorean theorem. So the hypotenuse of a 45, 45, 90 is the square root of 2, and the legs are 1. So we will have to remember that fact for our problems today. The next one we have is a 30, 60, 90. And to get these numbers for a 30, 60, 90, we have to start with an equilateral triangle with the sides of 2. And of course our angles are 60. And if I were to split this into half, this top angle would be 30, and this side would be 1. And so that's where we get this 1 from right here, our 60 here, and our 30 here. And of course, our hypotenuse is 2. And to get the other side, Pythagorean theorem. Square root both sides. We get x equals the square root of 3. So for a 30, 60, 90, the hypotenuse is 2, across from the 30 is 1, and across from the 60 is square root of 3. So we will have to know how to draw that for our problems today. So how do we actually use special right triangles to solve for missing sides? Well, I have a 3-step process. The first one is you have to find out which special right triangle you have. You're either going to have a 45, 45, 90 or a 30, 60, 90. Once you figure out what kind of special right triangle you have, you're going to draw the base of that special right triangle, which we just did. 45, 45, 90. The hypotenuse is a square root of 2, and the sides are 1. For 30, 60, 90, our hypotenuse is 2, across from the 30 is 1, and across from the 60 is a square root of 3. Once we've written down our base triangle, we're going to set up a proportion and solve. So it's just a 3-step process. Let's try our first example. So right here we have a 45, 45, 90. And we're going to draw a smaller, identical triangle in the same configuration as we have on the right, except now we're going to label it with our base triangle values. The legs are 1, hypotenuse is square root 2. Okay. Now I'm going to set up a proportion and solve. Triangle 1, triangle 2. I always like to start with my variable, so I'm going to start with x, and that corresponds with the square root of 2 on triangle 2. We go back to triangle 1, the value they give us is 5, and that corresponds with 1 on triangle 2. Next, we're going to cross multiply and solve. So we get x equals 5 square roots of 2. Let's do another example. Now this one doesn't have any measurements inside the triangle, but we know that this is a 45, 45, 90 because these two sides are exactly the same. So it has to be a 45, 45, 90. So we know it's a 45, 45, 90. And so we're going to draw another smaller triangle, a mini one, with the base values. Legs are 1, hypotenuse square root 2. We are now going to set up a proportion and solve. This is triangle 1, this is triangle 2. I always like to start with my variable, so I have x over corresponds with 1 equals, go back to our original number they give us, 7 square roots of 3, which corresponds with the square root of 2. We're going to cross multiply and solve. we get the square root of 2 times x equals 7 square roots of 3. We can now divide by the square root of 2, and we get 7 square roots of 3 over the square root of 2. Now this is not our final answer because we have a radical in the denominator. So to get rid of that, we have to multiply by the denominator by the top and the bottom. So what we're going to get for this is 7 square roots of 6 over 2. All right, let's try a 30, 60, 90. So this is a 30, 60, 90. We're going to draw another smaller triangle. Right angle is in the same place, 60 degrees is in the same place. Hypotenuse of a 30, 60, 90 is 2. Across from the 60 is square root 3. Other side is a 1. We have to solve for two variables here. So set up our first proportion, and we're going to solve for t first. So it's going to be t over 2 equals 5 over the square root of 3. Cross multiply and then divide. So t equals 10 square roots of 3. But don't forget, we cannot have a radical in the denominator, so we have to multiply by the square root of 3 by top and bottom. And so we get 10 square roots of 3 over 3 is our value for t. Now we're going to solve for s. So we're going to set up a proportion. S over 1 equals 5 over the square root of 3. So we have the square root of 3 times s equals 5. Divide by the square root of 3. S equals 5 square roots of 3. Cannot have a radical in the denominator, so we multiply by the square root of 3 over the square root of 3. And our final answer for this is going to be 5 square roots of 3 over 3, and that's our value for s. All right, let's try one more of our 30, 60, 90. So we have a 30, 60, 90. We draw an identical triangle right next to it, but with the values of our base triangle. Our hypotenuse of a 30, 60, 90 is a 2, across from 30 is 1, and our leftover is square root 3. Let's set up a proportion. Let's solve for f first. So we have f over 1 equals 11 square roots of 5 over 2. So we have 2f equals 11 square roots of 5. Divide by 2. So f will equal 11 square roots of 5 over 2. Next one we're going to solve for is for g. Oops. So that's going to be g over the square root of 3 equals 11 square roots of 5 over 2. Cross multiply and solve. 2g equals 11 square roots of 15. Divide by 2. G will equal 11 square roots of 15 over 2.